Hey, let's take a quick time out for some great news. Open enrollment is here. DigitalWorks Academy is offering a series of courses on model-based systems engineering. First up, an introduction to Mbse. This short course is designed for executives, managers, and senior leaders who want to know more about model-based systems engineering. The course explains what Mbse is, why it matters, and how it can improve the scope of projects from cost to schedule to quality. You will be more than ready to support your organization when it inevitably moves to Mbse. Again, enrollment is open right now. To make sure you have a seat, scan the QR code on your screen or go to the link at our website, digitalworks.org. To make sure there's a spot for you, register now. Enrollment is open. Hello, everybody. I'm Steve Johnson. This is DigitalWorks TV, and with me today is Tara Shifflett. Now, Tara, and a special guest if ever there was one, and I have to read your title because it's significant. You're the Chief of Technology for KBR Defense and Technology Solutions Business Unit within Mission Tech. Okay, our next 30 minutes of this interview will be about what the heck that means. But what does that mean?
As the Chief of Technology, one of my focus areas is ensuring that what we're doing from an engineering standpoint across our division, across our operating units, along with sister divisions is consistent, that we are bringing best value to our client base, regardless of who that client base is. Specifically, some of the areas I focus on: digital engineering, the digital accelerators associated with digital engineering, model-based systems engineering, environments, and kind of all of the things that we want to be able to do at scale to support our clients across every DoD branch. So I reside here in Huntsville. I support our Army clients with the majority of what I do, but because KBR is a large multinational organization, we try to leverage best practices across what we're doing for not only DoD branches, but for our commercial customers, our space customers. And so as a Chief of Technology for this division, I work with my peers in those other organizations for consistency across what we do.
Okay, so the description of your job is a page. Okay, but just because I'm the kind of guy who always wants to know what initials stand for, does KBR stand for something?
Kellogg Brown Root, right?
Okay.
So that's the.
Okay, so now I know that.
Yeah.
And it does strike me, and we're going to talk a lot more about model-based systems engineering, but that what you do is kind of keep your arms wrapped around a big old corporate system. Is that correct? A correct way to look at it?
Yeah, it is keeping that in alignment. Let's just talk. Let's say that.
Okay.
What we're trying to do is keep alignment, because there's opportunity when you're such a large organization and when you're trying to solve very difficult technical problems for a lot of different clients, for you to do offshoots of this is a one-off.
You want everybody on the
this is a
same page
one-off.
doing things the same way in
Right.
every case. Okay, so we met because you go to Nkosi. I'm going to let you say what Nkosi means.
INCOSE, International Council of Systems Engineers.
Okay, so you're on the corporate advisory.
I am a corporate advisory board member for KBR to INCOSE. And I am active here in the local Huntsville chapter. So we do have a very active local Huntsville chapter, which I'm very proud of, and it's continuing to grow. And I think that the things that INCOSE is focusing on with their strategy over the next 5 years, specifically around what we're doing in digital engineering, specifically around model-based systems engineering, and the outreach we have to student INCOSE organizations is very exciting to me. So,
okay, so once again, that's making sure everybody's kind of on the same page.
Yes.
And one of the things, I guess, one of the drives for you and for INCOSE and for the people I work for is everybody kind of getting on the digital engineering page, which, once I learned about the way things used to be done with a lot of paperwork and having big meetings and things like that, it's hard for me to understand that everybody didn't say immediately, yeah, let's don't do that anymore. That's such a pain. And so, but everybody isn't doing it the new way, which would be model-based systems engineering, are they?
They're not. And I want to level set a little bit about terminology, right? So digital engineering is very specifically using a set of tools to produce artifacts that support your engineering decisions, right? So when we talk about model-based systems engineering, it's still systems engineering at its core. That's why systems engineering is in the name. But when you use Mbse, you are using a specific vernacular. You're using a specific methodology to now do the work you had done previously that may have been done a thousand different ways, right? So digital engineering is very specific around the tools and the methods.
Okay, so just for, and you're explaining to me like I don't know, and you're right. I kind of do, but digital engineering, I mean, at bottom line, it's doing things on computers that might have been done other ways in the past.
Right. So I use this example a lot, and I used it with the VP of our division, and that's kind of when the light went off for him, right? Because what you're trying to achieve with digital engineering is digital transformation.
Yeah.
Right. That is the behavior that you're trying to enable. And so I was explaining, I said, you and I are of an age where we probably remember interoffice memorandums, right? So someone would have to type out and either type it on a typewriter or print it out maybe on a printer and put a piece of data inside of an envelope. And that envelope would have, send this to Joan in finance. And then a courier would come pick it up and it would go to Joan in finance. And Joan in finance would open it and look at it and make a decision on the information that was in that. And then have to do the same process to get it back to you. Very analog, very time consuming. Then email came along. So now I can instantaneously, almost instantaneously, contact Joan in finance and say, I need your information on this. So now I've cut out not only the transit time, physical transit time, but the personnel that were needed for that, right? So I no longer have an interoffice courier.
So Joan has lost her job.
Well, no, Joan's still in finance, but maybe the courier doesn't, right? But now maybe the courier is learning how to do finance work. But then, and email was kind of our de facto first digital transformation in an office, right? And not only can I send this to Joan, but I can send it to 12 other people along with Joan, right? And then we kind of evolved again using other tools. So collaborative spaces came on board. Microsoft Teams came on. So now instead of email, I have a chat feature and I have collaboration rooms where everyone can look at the same document at the same time. I don't need to attach it to an email to Joan. I can bring Joan into a collaboration space and we can look at this document at the same time. So the time it took to make decisions based on information I needed to give to Joan has gone from I need to write an interoffice memorandum, send it through a courier, she needs to get it, come back, to, hey, hop on a call with me and let's collaborate in this space. That's digital transformation, right? And that's using digital engineering tools, because Teams is a digital engineering tool. Word is a digital engineering tool. Those are tools to allow us to make decisions faster and with information that is more democratized. Other people can get to it. Other people can make understanding on it. And I think that's what I'm excited about, is that the talent we have coming into our industry right now were born in that ecosystem. That's how they've always collaborated. That's how they started middle school, right? They know how to do this.
I'm of an age, as you said, that didn't do it that way.
And so they're going to come into this workspace with this expectation of being able to collaborate. And that's what is exciting about model-based systems engineering now, is you're collaborating in a model, and that model is defining a system where people can make decisions early in the definition, early in the design, early in the product phase and the business needs and understanding risks, and collaborating it across multiple disciplines in a way that we've never been able to do before. And that's what I find exciting about it.
Okay, so I have a question, but I want to. You're a systems engineer. You do systems engineering.
I do systems
but
engineering,
you
yes.
are by education an electrical engineer.
Yes, correct.
But isn't that the case with I won't say most, but a lot of systems engineers, maybe even most, where they started out as one thing, and I hear electrical engineer or mechanical engineer as the basis for a lot of folks, and just by nature of what they're doing, they had to become a systems engineer where they looked at the whole system,
Yeah.
product.
Yeah, I think I'm going to be biased for a moment and say, obviously, electrical engineers make amazing systems engineers. That's bias. But I think what happens is over your career, you are forced to deal with integrating hardware and software. Electrons have to move through things. Heat has to move through things if you're mechanical, but electrons have to move through things. And so you are constantly dealing with integration at a boundary condition between two systems. And that's all systems engineering is I need to get information from here to here in order to have a capability or to have some sort of function emerge. And so if you have gone through the process of learning what a boundary condition looks like, how to integrate a piece of hardware with a piece of software, then you start to understand, well, where does this function now reside most natively? Where can I get the most use out of it? And that starts to fuel systems thinking, because I think one of the things we lose track of when we're talking about systems engineering and we talk about the benefits we're going to get out of that with Mbse is modeling for the sake of modeling and creating a one-off model is not where you get the benefits out of Mbse. Where you get the benefits is understanding how can I now make this a product that I can use again and again, right? How can I make this an object that I can use it again and again and get an efficiency out of that? And I think when you come out of an engineering discipline where you have to reuse some sort of product or some sort of component again and again, you see that pattern recognition, and that's what leads into good systems engineering, in my opinion.
Okay, so you talked just a moment ago about how people coming to your world now come to it thinking digitally or thinking a new way.
Yeah.
But everybody working did not come to it that way.
No.
So is some part of what you do, and you said the light went on for a guy you work with, so is part of what you do is kind of sharing or sharing your world and getting them to see that this is a really good world that we all ought to be in.
Yes, trying to be a good advocate, an evangel, if you will. One of my favorite authors is Douglas Adams, and he has this quote about technology that says, any technology that exists in the world when you're born is just the natural order of things. It's just how it exists. Any technology that's invented when you're from age 15 to 35 is cool and interesting and exciting, and you could probably get a career in it.
Yeah.
And then any technology that comes along after you're 35 is witchcraft and against the order of things and should be burned to the ground. Right? And that's a little bit of how
I might even believe that.
and that's a little bit of how I think about the adoption of Mbse.
Yeah.
Right? Is we've got again the kids coming out of school that SysML is just a tool they're learning. That's just it. It's how we do systems engineers. And then you've got kind of the system engineers that grew up to become system engineers looking at this going, I do my job anyways. Why do I need this? And so my job is to make it look less like the witchcraft that needs to be burned. And that means there has to be a value proposition. What's in it for me?
Yeah.
And I think where we get the most value out of those deep SMEs that are systems engineers that have been around a long time is not necessarily in teaching them SysML or Mbse, but using them as a stakeholder for the practitioners of Mbse to refine that modeling, to refine the understanding of the system, right? So there's that's kind of where that generational exchange happens. Is I've got a deep SME, maybe I've got a deep radar SME, right? Special subject matter expert, and he knows everything there is to know about radars. Does not want to know Mbse, and he doesn't need to know.
Yeah.
But what he needs is an MBSE practitioner, that he can say a radar consists of these systems. And the practitioner says, I can model that. I can create a system that looks like that. And then gives them the tools, gives that subject matter expert the tools to say, if I change this performance parameter, what does that look like in my model? Because now the point of your model is to help you make decisions. Okay. It's to help you understand implications of changes. It's to help you understand behaviors and functions and actions that come out of it. Things that he would have had to probably gone off and noodle away on a piece of paper later. So you have to bring a value proposition to the kind of the gray hairs like me and folks. Why do you care? Just shoving everybody into the model is not the right answer. Definitely not the right answer.
Okay.
But
I've got to believe, just from conversations I've had, that what you said with the subject matter expert, that happens a lot, where you have people who they really know a lot. They can help with the model the system you're working on, and there are things I don't want to know about. but they want to be included. But this feels like you figured out a way to make sure that we don't get rid of good stuff in our zeal to do it a new way.
Yeah, I think the important thing is that data that's not accessible or meaningful to a stakeholder is non-relevant data. And so when you are thinking about MBSE and you're thinking about the consumers of that information and how they'll make decisions, that is a very, very relevant thing for the developer to consider. What does my stakeholder need to make a decision? How do I present this information for them to make that decision? And there's just as much art in that as there is in the actual modeling itself. And I say it all the time. Modeling just for the sake of modeling is not going to get you the results that you need.
Okay, what does that mean? Modeling just for the sake of modeling. What does that mean?
It means if you are just going to take your requirements and throw them into a Cameo model or an MBSE representation, but you don't have a strategy on how you're going to use the information in there to inform your future decisions, then you've wasted your time and energy and money on creating that model. It has to start with the end in mind. What do you care about for that model in order to make decisions on it on a go-forward basis? Do you care about, lifecycle management? Do you care about interfaces associated with data bus types? Do you care about, weight? Do you care about thermal properties? What is it that you care about as an end user? And then you have to think about how to model and present that, because that's where you get the biggest bang for the buck in MBSE. Is it helps you make decisions on those changes later in the life cycle faster, more efficiently, and give you the understanding of the risk and the business case associated with it and that sort of things.
Do you end up having to explain why you don't model just for the sake of modeling to people who aren't, I won't say they're not sold, but they are the guy who's a subject matter expert, or who doesn't want to know all that stuff? But you have to explain, no, we're not just doing stuff here. We're doing stuff with a specific goal, and we need you to be part of our process. Do you have to explain that to some of the people who may be, and I don't know if pushback's the right way to describe it, but who have done it one way and it worked, and they really don't understand why they need to do it another way?
Yes, we have that conversation a lot. And one of the ways that we influence that is by showing proof models, right? And so we will generate and create a small model representation and say, okay, what do you want to do? What do you want to change? Tell me what's important. What's your next technology insertion? What is the next iteration of this product? What do you think? And then showing where I can go into this model, make these changes, and show all of the functions that are going to be impacted by that, all of the requirements that are going to be impacted by that, which is a capability that our clients didn't have before. Yeah. And so there is a lot of show me associated with adoption of MBSE. And I think that stems from kind of it being forced into the acquisition strategy as opposed to organically growing within the acquisition strategy early on. And so because it was kind of forced, there wasn't a lot of thought put into, okay, what is my bare minimum to start with to show success? It was just go do this. And so now we're in the catch up of, you did it. Now what's the goodness out of it? How do we make sure that the models that you created, the architectures that you're representing, the investment that the DoD clients have made, where now can we leverage that into their future? Which is really hard when you're talking about large-scale weapon system programs, which is a lot of what we do here in Huntsville, right? Because they have such long life cycles. It's a long time from the time you get an initial requirements document to, here's the thing, it exists, and we're not going to change it for another 5 years. So why did I spend all that money on model-based systems engineering if I'm not going to change it? So I think that's where we struggle in the DoD world. But I think on the flip side of that, in the commercial realm, and when we talk commercial, we're talking Ford, GM, large OEMs like that, have embraced Mbse and have been doing it for quite some time, 2 decades at least, because it allows them to manage a product line strategy. And that is hugely important to them when you have a profit margin.
Yeah, I was going to say, so
right?
What you said, and I get it. If you're working on a military thing, if it's important, there's a lot of money.
Yeah. There's
a big pot of money, and it's, but if you're making a car, it's like, we've got to get the price per unit down.
Yes.
And so, will this help us do that? So, isn't it amazing how everything comes back to money?
Always will.
So the more economical you need to be, and even taxpayer money is finite, as we well know.
Right.
So Mbse is a real, or all of this is a real good way to do that.
Yes. So as many people know, the Congress, Title 10 law is that you shall consider a modular open system approach, MOSA, on any acquisition or any system. And so that's kind of DoD speak for product line. Think about what your product lines are. Think about how to leverage the modularity of a system or a series of functions into a capability so that I can do a design once and field to many. But the only way to really successfully do that is to represent that in a model, and that model then can be vetted against multiple systems of interest, whether that be I'm going to develop a navigation system model and see how it integrates against Army aviation platforms, and then against Air Force aviation platforms, and against Navy aviation platforms. But that's a product line strategy looking at a particular system, its boundary conditions of that system, which you've represented in Mbse, the functions of that system, and then where do you have opportunity to use it in more than one place. And that's kind of the efficiencies that Mbse brings to digital engineering, collaboration, and being able to do that design once, field to many kind of strategy that we want to move forward with.
And plus, like on a car line where you realize, those brakes don't stop as well as we thought they would, even as well as we tested. Yeah. So we need to change the brakes. We got to figure out, though, how to make it fit within whatever the size of and so that the Mbse would help there, and it would help with a missile system that you may have fielded 10 years ago. Mm-hmm. And somebody says, hey, we can get more power to the guided system, but we've got to change the size of the battery. And so as you go along, Mbse allows you, and I know you know that, I'm not telling you that, but I'm explaining it out loud to myself. But that's where Mbse is crucial, is being able to make changes not only down the line, but quickly down the line.
Right. And That's when we get to discussions about virtual prototyping versus a digital twin, and what can you do in a virtual prototyping environment, and what can you do once you have a digital twin and representing changes that you're making, and all of that is enabled through model-based systems engineering. And again, we're trying to shorten the distance between data and decisions.
Okay.
Right? That's what we're trying to do. We're trying to speed up decisions, lower risk, and lower cost. And so the more we can do in a virtual environment where we're taking a Cameo model and maybe we're running it against some sort of faster than real-time simulation environment that allows us to see the impact of the changes that we've made and go, okay, are we in the ballpark? Or how much is this going to cost for us to do this? And it allows us to make those decisions earlier in a program, which obviously makes them cheaper, right? When we take that back to systems engineering, traditional systems engineering follows this V, right? So you design, you build, and you test. And then we go into a test, fix, ad nauseum, which is extremely costly. And so what digital engineering is trying to change that dynamic from design, build, test into model, analyze, build, right? So you have a significant amount of information that you have now made decisions on virtually before you get to the build phase. So a lot of verification activities in a virtual realm, a lot of validation that's happening. Now I can build and I can see where the intersection has happened between my reality of the thing that exists in physical space and the virtual prototype that I created. And then that allows us to mature the models even further, saying, okay, what did we miss? How does this really act in the real world? And how do I now bring that back into my virtual space to make the next model in simulation even better?
Okay, what you've been saying, do you have to actually say these things to various, but to engineers, to companies, to subject matter experts? This isn't the first time you've said it. I
may have a stump speech, yes.
But do you have to say this a lot? I mean, and does it even surprise you that you have to say it this much, or as much as you say it?
It doesn't surprise me that we're having these conversations as often as we're having them. But as you stated, it's kind of a refined stump speech for me at this point, right? Because I'm very passionate about it, and I think that there's so much opportunity in this space for us to be better than what we are. I think that engineering as a whole has been kind of throttled back on what we could bring to a marketplace or what we could bring to the physical world based on a lot of gated decisions. Yeah. And so now when we are in a virtual space and we're collaborating and we're modeling and we're simulating, your data supporting your decisions is more real. And I think that that's going to unleash our ability to get more product out faster, whether that be a physical piece of product, whether that be software, whether that be some sort of data as a service. But I think that's what I'm excited about, and that's why I continue to have these conversations with people and with our stakeholders, internally, externally, clients, to see the potential that there is in not only Mbse and not only in digital engineering, but to achieve really digital transformation within their organization.
Okay, so you're a true believer who's sharing the faith. Is that would be one way to describe it?
Sure.
Okay, but you got your engineering degree at Mercer.
Mercer.
It just strikes me. So when you got out of college, it was probably 3 or 4 years ago.
Yeah.
That this was not even something. Talk about not on the horizon. Nobody even. This wasn't your world. Your world was being an electrical engineer, right?
Yes.
Okay, so when can you remember? I'm sure you can, but when you went from doing things, which I would assume, for most things, last year was the old way, but
it's going
but
fast,
doing
yeah.
things a different way. And do you kind of remember the process of when the light started coming on for you about this world that's out there where we can be quicker, more economical with everything we do?
So I was kind of forced into it. So as you said, my undergraduate degree is in electrical engineering. My graduate degree is actually in electromagnetic field theory. I thought I was going to go work on antennas and EW type stuff. That just didn't work out based on what was available in the job market at the time. So
But
I started
you could still
off,
fall back on that, right?
no, absolutely not. Maybe Maxwell's equations. I don't know. But I started off in DoD and doing work at Robins Air Force Base, working on test stands, because that, it was close, and that was kind of integrating and having to understand how to test things, right? And that was just kind of business as usual. You built this huge hardware test bench. It was just what you did. You put all the actual LRUs in there. Somebody went in and pressed all the buttons and made sure this does this test and it passes this test. A very manual process. And then from there, I went and took a job in commercial aviation and worked for a large supplier to commercial OEM. And that was kind of the first introduction to automated testing. So someone was now writing a script, and that script was gonna exercise those units. And I was like, well, that's cool. That's faster. That's way faster. That's interesting. And so I started to explore what are ways that we could make that even faster, right? What are ways that I can take this 6 weeks acceptance test program and make it into a 2-week acceptance test program? So really, I started to become fascinated by efficiencies and how to become more efficient at what we were doing. And then I ended up on a program where a lot of the work was done over several locations globally. Like on a daily basis, I was having to engage with people that were in Japan, in India, in France, in the West Coast of the United States. And we didn't have a lot of time to slow us down on making decisions because we were trying to integrate big systems that were going onto a moving production line. You don't want to stop a moving production line. And so that was the first time I had the opportunity to create collaboration spaces, right? So how do we get information to these folks in Japan that are basically going to be making a decision overnight on something I sent them, and then I have this information in the morning? Having collaboration spaces with people that were doing, testing for us in Asia and in India, and then giving the results to the people that are on the West Coast, and creating a team of teams to get information from one place to another. And that's when I started to really focus in on systems engineering, because I saw that as a system. And we now need to be able to collaborate. We need to make decisions quickly. Otherwise, we're holding up, certification of a very large aircraft. The production line could stop. So there's a lot of factors that cause the pressure that create the innovation of how do I create this collaboration space? How do I make sure that people have the right information at the right time? And that's when I started to really focus in on that aspect and kind of leave behind electrical engineering and do integration and systems engineering and digital collaboration. And then from there, I went to work at an OEM, which was an even different experience altogether, because now you're the one taking these systems from all these disparate places, and you got to make them all work together. And you're just hoping you gave everyone the right requirements at that point. So how are you ensuring that the requirements you gave them were the right requirements? Well, you create a model, right? And so that was kind of the very early exposure that I had to model-based systems engineering. Was I had to give, these system requirements to this supplier and this supplier and this supplier, and they all now need to come together, and I need to validate that in an environment before I go and spend a whole bunch of money on, testing or integration activities. So that was really where I had that first experience of that, and then brought that into continuing to work in the work that I do here in Huntsville for our Army client.
Was it lucky for you that you came to it that way? But like you say, the new people,
Yeah,
this is their world, but you kind of saw their world created.
I did.
And that it seems to me that you're not uniquely suited, but you are suited to spread the word because you know how it was before.
Right.
Does that help you when
Learn
you're
from
trying
my
to talk
pain.
to people?
Yes,
Yeah.
there's a little bit of learn from my pain there that we get to have. I consider myself fortunate because I get to mentor a lot of our junior engineers, and one of the things I try to focus on is in systems thinking is think about as you are creating your model, like you're going to give this to someone and they need to make sense out of it. And you could be giving this to a subject matter expert and they're going to look at it and say, you totally missed the mark. You don't even know what the system is supposed to do. Or you could be giving it to a client and the client would say, I don't understand what you did here. And so one of the things we really try to focus on in the model is how are you conveying this information in a way that a layman could understand it? Because ultimately that's what we're trying to get to, is that anybody can use the information.
Just because everybody at every company is not an engineer.
Right, exactly. But everybody will make a decision.
Yeah.
Right? So we find ourselves in situations where, we've created an Mbse representation of something, and the decision maker is completely non-technical whatsoever. Right? And so how are you going to present this information to this decision maker from a model? Sometimes that means that you're exporting it into a Word document. Sometimes it's now an Excel file. Sometimes it's got to be presented in a way that makes sense to the decision maker until those decision makers cycle out and become more conversant in MBSE.
And I would think if you're a decision maker in the kind of companies you work with and for, that if you don't become knowledgeable, you're not going to stay.
Yeah, I think it becomes that you become circumvented. I mean, it's like, I think that ultimately decision makers, we do it now, right? Except we don't use MBSE, we use PowerPoint.
Yeah.
No decision maker in an organization is reading a 10-page white paper on why he should do this versus this, right? That decision maker is like, give me a one-pager or a quad chart or something that tells me what's been done, what's the problem, what are my COAs, what are my risks? And then they make a decision from there. So how do you create that experience for them out of a model, right? What's the problem? What's been done? What are my COAs? What are my risks? How do I create that for them? Because that's ultimately what they're making decisions on.
Okay, and all of this in the midst of a world that is not stopped at one thing.
No.
Like you mentioned digital twins, and I realize that's not brand new, but that's a thing that people are becoming more conversant with. So I guess, but your world, you're explaining it, and you probably get to the point sometimes, I wish could we just stop here?
Take a breath.
and not get this new thing that we've got to now incorporate in everything we're telling people.
It's funny you bring that up because I think it was yesterday, the object management group finally approved SysML version 2. So just when everyone was getting good at version 1, version 2 came out. Right, and so now we're all going to learn a new version of SysML that's going to.
And while that's a pain, it's also a great thing.
It is.
That your world is getting, your world and the world of every other systems engineer is getting better.
It is. It shows that we are thinking about how to progress the language to be better at what it does. And that's ultimately what you want to do in engineering. You ultimately want the next thing to be better than the previous thing. And so, you don't want to get stuck on, well, this version of SysML, it's fine so long as you know to do this and you do this. So by evolving the language and evolving how you use it for model-based systems engineering to make it better, I think is going to help in adoption. And it's also aligned to really how the next generation of engineers coming out are going to think about systems engineering, because syntax, how it's structured syntactically is very much going to align with how they've been coding for a long time. And so I think that I'm excited about how the native capabilities that next generation engineers are going to bring to SysML2 and how they're going to use it.
Okay, is there, in your mind, do you ever you're so busy with all you have to do, probably not. But do you ever consider how different it was 5 years ago and how different it might be 5 years from now?
Yes, and I know people have been on this bandwagon for a while now, but what AI is going to bring to model-based systems engineering is going to be huge, right? The way that we interact with AI-enabled Mbse, creating that interface that allows you to we talk about getting through the muck, right? Because there's a lot of very manual things that you have to do to create the model. Well, now I can use AI to do that. I can use an AI agent to say, okay, create these functions for me that have this capability, and it's going to spit out the code that allows you to do that. And so kind of I call it muck work. We do the same thing in software coding, the muck work. You now have an AI agent and a trusted AI agent that can help you
We could have a whole conversation about trusted AI agent.
Yes,
I've seen the movies.
Yes. Yes, we could. But I think that's one of the things that's going to be so different between now and 5 years from now is how we start to generate models and what that initial model looks like before we start to bring in subject matter expertise.
Okay, I'm just curious. You think that as AI and things we're not even doing yet, we start doing, that there will be people who are all gung-ho right now who will start pushing back because they will have reached the point where they don't want to go to the next thing. Is that, do you see any of that yet? Or
it's interesting. You see early adopters in this space a lot. They get very excited about the thing they're adopting. And then when they get leapfrogged, they're like, no, wait. I'm not done with this thing yet, right? You didn't achieve the full potential of this thing. And that is sometimes the unfortunate aspect of as fast as the technology is advancing is you may not achieve the full potential of what you could do with this version or with this slice of technology or digital engineering before it gets leapfrogged, right? So yes, we talk about AI, and that is a digital accelerator. What's the next one? Quantum computing. So you've got, AI folks that are really on the bandwagon there, but now I've got the next bandwagon of folks, quantum computing, going, yeah, but if you could use this. And so I feel like we're going to be constantly in that churn, but understanding what is the best possible outcome we could get from those digital accelerators, and then applying that to the problem at hand is still light years ahead of where we were before that digital accelerator was available.
And it is a world where it's get on board or get left behind.
Yeah, it is. I don't think it will become survivable for a company to use what we consider more traditional engineering methods, right? Only because the space between where early adopters will be and where you get on will just continue to grow. It's going to be an exponential growth. It's kind of like companies that are now getting into AI thinking they're going to home grow their own AI, but AI is already so far advanced that this investment here, you'll never be able to invest enough to catch up. And that's where companies that don't get into digital engineering will be, is that you'll never be able to invest enough to catch up to where the people that adopted early on will be.
Okay, and scary or exciting?
Both. It's really both. I think it's exciting because I think that the technology that we will be able to achieve will be tremendous, but what we do with that technology could be scary, right? I liken it to.
But it's always been that way, hasn't it?
I mean, I listened to this digital disruption podcast, and they had the gentleman who was the chief technology officer for Google on, and he was talking about AI, and he was like, he uses Superman as the example. Superman came to Earth, and he happened to, be adopted by parents that were of a good nature. Now, imagine if they were supervillains, right? Yeah. You would have a different Superman. So AI is kind of that way as well. So depending on the adopters and what the adopters natural bent is. It could be super good, it could be super bad, right? But I think it's exciting either way because it's going to bring new technology so much faster than before. And again, we have an entire generation where this is just native for them. The way that they use AI is native. Like, kind of older adopters of AI, we use it kind of like Google. Hey, Copilot, tell me this, right? They use it more for problem solving. Yeah. Give me a budget that tells me to do these things on this time frame. And so it's a different mindset of how to engage the technology. And I'm excited to see what that generation brings forth.
Yeah, and once again, looking at your job title, you're going to be busy.
I am busy, yes.
All right. Thank you so much for being
Absolutely.
with us.
Thank you. I appreciate
Tara
the time.
Shifflett from KBR with about a 5-sentence job title. Anyway, thank you.
Thank you.
And thank you for joining us. And remember, this is on Digital Works TV, and I guess that's almost stupid to say because that's where you are. In any case, thank you for being with us. And don't forget, it works.